Okay, only one people joined. I'll wait for 3 minutes, 6:15, then I will start the class. And I'm sharing my screen as it is my duty to record this class and upload it in YouTube, and I have to give it to NPTEL PMRF team. So I'm starting the class. So I am audible or it is visible? Can anyone tell? Okay, no response. One minute. Okay, today I came with few questions. If you solve it, then it will be better. And okay, first question is first is we'll calculate the energy different energy levels of benzene molecule. Okay. So here I am giving one equation. First we have to determine the secular determinant, then we can solve it. Sir already discussed in the class how to calculate that thing. So now here I am just giving one equation from where it is came from the solution of secular determinant x to the power 6. Here x equals to alpha minus e by beta. B is the alpha and beta. Sir already discussed all these things. What are the terms here? And E is the energy value. Okay, now we'll solve it. First, how to solve it? So this is normal 12 plus mathematics, but again first you have to think hit and trial method that I usually do if x equals to plus minus 1, because these terms are even, so plus minus doesn't change anything, is equal to, then what will be the value? 1 minus 6 plus 6 minus 4. So, what will be the minus 3 plus 3? It will be 0. So, x plus minus 1 is the one of the factor of this equation. So, first, one solution is x equals to plus minus 1, then it is satisfying. So now for getting the other thing, other x value, I am just dividing with minus 1. These are the only mathematics, but if you want to learn quantum, then mathematics is mandatory. X to the power 4, then so that it is cut, minus 5x square plus then x to the power 6, and it will be first x to the power 4 you multiply x to the power 6 minus x to the power 4. Okay, then what will be the 5x to the power 4? Now 5x square, as we want to deduct this thing, minus 5x to the power 4. We are multiplying this with this whole thing, then plus 5x square. 4x square minus 4, then plus 4. So 4x square minus 4 minus plus, then it will be 0. Then another factor, then we have to solve this minus 5x square. These are the only mathematics I am doing. But mathematics is required for if you want to learn quantum mechanics. If you don't understand anything, you can ask me. x1 plus minus 1 plus minus 2. These two are value. Then now what I'll put the value of x here. Another energy level value is alpha plus beta. These are the three energy level values. Okay, now I am drawing the energy level diagram of the benzene molecule. First is the beta is the negative. Which one is the lower value? This one will be the this one will be the lower value, as beta is negative. Alpha plus 2 beta, and these two are degenerate. Alpha plus beta. Then this one will be alpha minus beta. Alpha minus 2 beta. Okay. Now as benzene molecule having the now if someone ask you what is the value of the pi electron energy of the benzene molecule, then how to calculate that one? Benzene is a planar molecule, and it has all p orbitals are above the plane of the benzene ring, and so it has such a 6 electron. Now I am filling this orbital according to Pauling exclusion principle. Okay, 6 electron is filled. Then what is the total energy? Will be 2 electron into alpha plus 2 beta. Alpha plus, sorry, what I did, 2 alpha plus 4 beta na, within 4 8. This I have to check. I think I did some mistake here. 1 minute. If people are not asking any questions, so means I am also getting demotivated. I think it should be total energy we are calculating na. I will check this thing. I think I did some mistake, but these things are okay. 4, 2 and 4, 4 beta and 6 beta. I'll check this thing again and let you know in the next class. Sorry for the disturbance. I just want to see anyone is joined or not. Okay, leave it. My work is to up to that. If you people don't ask me any question, I am also means I am just doing. Okay, leave it. Okay, now next draw the molecular orbitals of benzene. Benzene molecule. So benzene hexagonal structure. Sorry, and let me draw. Why I am writing it degenerate to degenerate levels? I already showed that it has two degenerate levels, and these two are doubly degenerate. So I am writing it here like that. And each carbon is having a p orbital perpendicular to the plane. It doesn't have any lobe. Sorry, it doesn't have any node. I think you people know this thing regarding the sign, as it doesn't have any lobe. So these all are in same sign. You already did in organic chemistry, hopefully. These are the orbitals, and as it has one lobe, oh sorry, one node. It node can be go through this, node can be go through this. Only one node we need. Plus, these are the same sign. As it is, there is a node, so it will change the sign. So as they are in the nodal plane, so they doesn't have any sign. So this one is the second, and it has two lobes. So two lobes can be like that or like that also. Changing the sign. And it's having three node. So I already discussed those things, but you have to read it properly. Plus minus minus plus. Okay, so every node, so it has how much? No node equals to 0, node equals to 1, node equals to 2, node equals to 3. You people already did it in organic chemistry also. Here is the same case, and it is the um, alpha plus 2 beta level. Alpha plus beta minus beta, alpha minus 2 beta. Okay, this is the ground state electronic configuration. Electronic configuration, what will be? That I already showed you, 6 pi electrons. Now I am moving to the next question. 1 minute. The next question is one of the focal molecular orbital. Sorry. Molecular orbital of 1,3 butadiene is. These type of questions usually asked in competitive exams. So I thought if I discuss these things, it will be better for you people. Okay. Now the energy of the molecule of this orbit in terms of we have to calculate. The question is the it is a multiple choice question. In terms of alpha and region. These are the Coulombic integral and this is the resonance integral. So I already discussed all these things very detailed. So first is alpha plus 1.62 beta. Okay, we have to identify what is this. So first we already know beta is a negative quantity. So what whose energy will be the maximum? As beta is the negative quantity, its energy will be the maximum. So maximum means this one will be the lower. Okay, so means like that psi 1, psi 2, psi 3, psi 4. Okay, as it is a negative quantity, so its value will be the maximum. So I am designating it as the psi 4. Now they asked the energy of the orbital of the term of alpha beta. Okay, so how we will solve this? This is a means they just give these things for nothing. You just have to apply your mind, then you can easily solve it. You don't need to do all these things also. Here you see this is the positive positive negative negative. Okay, so what will be the orbital diagram? Wave function will be like that. Butadiene, no? So 4. So and first two are positive, plus plus. So the next two are the negative. Okay, then what is it is changing sign? What does it mean? This coefficient is negative now, so it is changing. So it is opposite. You know this opposite will be here. So it's having a nodal plane here as it is changing the sign. So if you draw the butadiene normal case, okay, so it's having node 1, n equals to 1. I already showed you here also n equals to 0. In the ground state means lower energy doesn't have any lobe. As you go up, the node number is increasing. So here node number is 1. So so it will be the answer. Okay, I will draw that, then you will easily understand, I think. Okay, for the first energy level, what is node equals to 1, that I already saw in the previous class. So you see it is matching with these things. So it is matching with this. So this is the psi 1, psi 2. So what will be the answer? The answer will be psi 2. I don't know whether you could understand or not, but this is, if you want to solve this type of question, literally you don't have to do anything. Just draw whatever they told. These two are the positive values, so it is having the positive sign, and it is, as these are two are the negative coefficient, then is these two are the negative sign. So the sign is changing, though there should be a low, sorry, node, I'm sorry, there should be a node. So for n equals to 1 means node number 1, what is the orbital? So it will be psi 2, means psi 1 doesn't have any lobe, psi 2 have only one lobe, psi 3 having two lobe, and psi 4 having, sorry, I'm telling you here the psi node. Okay, I'm writing it here. Node 0, node 1, node 2, node 3. So n equals to, here we are getting only one node na, so it will be, the answer will be psi 2. Okay, I don't know whether you get it or not. I think, okay, psi 2 the energy of atom. Okay, third question, sorry, I am now, I think it's fourth question. So the fourth question is, I have few questions. What is the maximum number of electrons that can be associated with the following set of quantum numbers? We have to calculate. I am giving the following quantum number. Okay, I think that's fine. So they are telling the what is the number of electrons. So we have to calculate. Okay, so what orbital they are talking about? N equals to 2 and L equals to 1. L equals to 1 means p orbital. L equals to 0 means x orbital. These things you already know. So that the orbital will be 3p orbital. Okay, and they are telling that magnetic quantum number m equals to, so magnetic quantum number 0, sorry, yeah, it's fine, 0 minus 1. So this one is by pz, this is py, and px. Sir already discussed all these things in details. As my question, as I am discussing here, it is a doubt clearing session, so I am solving some questions, and if you have any doubt you can ask. It's always encouraged. So for the m equals to minus 1, so py, this orbital they are talking about. So each orbital having, so it's having one orbital. So how much one orbital can accommodate? 2 electron, and they are having opposite sign. Okay, so the answer will be 2. Sorry, means 2. The next question is, they told that orbital angular momentum of p electron. Okay, they told them what is the orbital angular momentum for p orbital, for p electron. So what is the formula? L equals to L plus 1 h by 2 pi. Here for p orbital L equals to 1. What will be the answer then? 1 into 2 h by 2 pi. Okay, then this will be the answer. They for p orbital equals to 1, if they tell for anything, let's say L equals to 2 d orbit, what will be the orbital angular momentum? 2 into 3 h by 2 pi means root 6 h by 2. I think now you could understand. This is the only formula. You have to put the things here. Did you people are getting my parts? Let me check if anyone joined or not. Okay. I'll move to the next question. Sorry. Okay, next question is another question. This is a very interesting question. The electronic transition energy propyl radical is 4.8 electron volt. Theory. Okay, this is the question. What will be the answer? Okay, first we have to draw the energy level diagram of the propyl radical. So what will be the energy level diagram? It is 3 carbons. These things are already discussed. You please read about it. I am just here to solving the questions, or if you have any doubt you can ask me anytime. So propyl radical, this. Okay, so okay, they told that from Now they told that the uh, transition from psi 1 to psi 2, this is 4.8. So what is the alpha minus root 2 beta equals to 4.8 electron volt. Okay. Another thing is that now we have to calculate the transition energy from psi 1 to psi 3. So we have to what will be the thing, minus we have to calculate this thing, sorry, psi 1, sorry, minus alpha plus 2. Okay, we have to calculate. Then what will be the value? Root minus root 2 b equals to 4.8 electron. Now it will be here 2 into 9.6 electron volt. This will be the answer. Now I think no one is here. Okay, if anyone having any doubt, so you can ask me anytime. Now another question is, using our results for ethylene, we have to show Hc equal to Cd. Okay, I am giving two determinant. Okay, now we have to calculate Hc. These things are 11th class means mathematics. So what will be the thing? 2 alpha one. The another thing is you have to calculate the Cd. Okay. Now see 1 and 2 are equal. So we can say that Hc equal to Cd. Proved. Let's see any people is there or not. Okay, so I think no one is here. Okay, it's fine. So if you whoever watching this video, I just want to say, I am. This course is for yours only. If you want to, means if this class is for yours only. If you want to attend the class, it will be beneficial for you only. And means you can in this class you can ask any doubt actually regarding the things that are already discussed in the class. And I am also solving some questions, and you also can bring some questions from your end also. Okay, for today I just made these questions. Means if you bring some questions, or if you ask some questions, I also feel motivated. Otherwise, I am just telling, and so um, if you are not getting anything, please tell me. I will repeat it. Okay, I think that is enough for today. Okay. Uh, yeah, if we have any doubt, you can ask me in this lecture. So in this class, okay, I'm stopping it here. But please ask questions, and also I also feel motivated if you ask questions. I will also bring more and more difficult, not difficult means interesting questions for all of you. Means it should be both sided. I think so. Okay. I think okay. I'm ending the class here. So thank you so much.